Okay, welcome to Easy Math, guys. So today we are looking at section 0.4, which is algebraic expressions or operations with algebraic expressions. So an algebraic expression is simply an expression that is formed when numbers and symbols are combined using operations of addition, subtraction, multiplication, division, exponentiation, and extraction of roots. So when any of these algebraic operations or more than one of them is used to combine symbols, then the resulting expression is called an algebraic expression. For example, the expression cube root, right, of 3x cubed minus 5x minus 2 divided by 10 minus x is an example of an algebraic expression in variable x. This is an example of an algebraic expression in the variable x. And an expression like 10 minus 3 square root of y plus 5 divided by 7 plus y squared is also an example of an expression in the variable y, and so on. While an expression like x plus y or cubed minus xy is an example of an algebraic expression in the variable y. So these also, they are called algebraic expressions because these symbols, right, constants that are represented by symbols, have been combined using these algebraic operations of addition. In this case, this is exponentiation, where it's been raised to an exponent, and this is subtraction, and then this is multiplication over here, and then division down there, and the extraction of roots here, where we have the cube root, right? So when symbols, numbers represented by symbols are combined using these operations, what we get in as a result is called an algebraic expression. Okay, so we can combine two or more algebraic expressions using any of the operations that I have just mentioned. Okay, so let's start with addition. We can actually be able to add two or more algebraic expressions. We can be able to add two or more algebraic expressions. For instance, given 2x squared y minus 2x plus 1 as one expression, plus 4x squared y plus 6x minus 3 as another expression. We can add these two algebraic expressions by adding like terms, all right? So by adding like terms. So a term in an expression, first of all right? So given this expression, for instance, terms are separated, expressions, individual expressions separated by addition and subtraction signs only, okay? So quickly, let me just recap what are the difference between terms and just expressions. So given 2xy plus 2x plus 2, right? 2xy is one term in this expression, 2x is another term, and 2 is also a term in this expression, all right? Notice that in this term, X and Y are not separated by an addition or a subtraction sign. So both of them come together to form one term. Okay, in other words, XY is a single term, whereas X plus Y is the sum of two terms, this term and this term. That's the difference. Terms are only separated by addition and subtraction signs. X minus Y is also one term, two term. Okay, X over Y is just one term. X times Y is also one term, whereas these are two terms and these are also two terms. So take note when I say a term in an expression, what I am referring to basically. Okay, so we add and subtract like terms whenever we are adding two algebraic expressions. So like terms are terms that are the same, basically. They look alike, all right? They have the same variables. The difference between them is just in their coefficients. Like terms are terms that differ only in their coefficients. For instance, this term and this term are like terms, all right? Because the difference is only, so another definition I want to also add is the definition of a coefficient, all right? So the coefficient of a term is just, for instance, if I have 2x plus y plus 5z, for instance, all right, x, y, and z are variables because we don't know their exact values, all right? X can be any real number if we are working in the space of real numbers. So can be y and z. Okay, so these are called variables because their values can vary. Whereas 2 here is a constant and it's called the coefficient of x. Here the coefficient of y is 1 and the coefficient of z here is 5, basically. All right, because 5 is a constant, 5 is 5. 5 cannot be anything else. But z can take any real number since we are working in the real number space here. Okay, so that's what I mean by coefficient, basically. So, like terms are terms that differ only in their coefficients. For instance, this term contains x squared y. This term also contains x squared y, so they are like terms. This term contains x, this one also contains x, so they are like terms. The difference between them is just in their coefficients. This is a constant, this is also a constant, so they are like terms. So in adding two expressions, what you need to do is just to add like terms only. So if I add these like terms, it will look like 2x squared y plus 4x squared y minus 2x plus 6x plus 1 minus 3. Okay, now every time you are adding terms in expressions, you must maintain their signs. Every term is read together with its sign. For instance, all right, negative 2x is read as negative 2x and not just 2x. So if I have the expression 1 minus 2x, all right, the sign of 1 there is plus, is positive, while the sign of 2x there is negative, basically, all right? So if I'm to read it here, this term is the term negative 2x and not just 2x. Take note of that, while this term is the term negative 3 and not just 3. All right, so take note of those basics. Okay, so we continue to add and subtract our like terms. So 2x squared y plus 4x squared y. So when adding like terms, all you need to add is just the coefficients, right? Then you write the variable the same way it is, okay? Just consider these to be bananas, maybe, and bananas. So I'm saying 2 bananas plus 4 bananas. So what it gives me should be 6 bananas, basically, right? That's how you should see it. 2x, negative 2x plus 6x, right? Minus 2x plus 6x. So what I need to do is to add up their coefficients, all right? And then just maintain the variable. So it's a 6 minus 2, which is 4x. Then 1 minus 3, which is a negative 2. So that is then the sum of those two expressions by addition, all right? And all other expressions are added in like manner, just by adding their like terms. Like terms add up together. So we can also subtract two expressions. If we were to subtract these two expressions instead, how would it look like? So it will be 2x squared y minus 2x plus 1, all of this minus 4x squared y plus 6x minus 3. Okay, let's say we are now subtracting. So the first one was addition. The second one is subtraction of algebraic expressions. Okay, so if we are subtracting, so again, our expression, let's take another expression, 3x squared y minus 2x plus 1 minus 4x squared y plus 6x minus 3. Okay, so what do we get? We get 3x squared y minus 4x squared y. And then we get a minus 2x minus. Okay, so with the minus, what you do first is to open up the brackets. And we do that by distributing our minus sign to each term in the second bracket. All right, so it becomes a 3x squared y minus 2x plus 1 minus, so the negative sign comes to there and it becomes a minus 4x squared y minus the negative sign also comes to the 6. It becomes a negative 6x, and negative becomes positive, so it becomes a plus 3. So the negative sign is actually distributed to each and every term in the bracket. Okay, so once that's done, we can then add and subtract like terms. So look at this term and this term are like terms, all right? This term and this term are like terms. This term and this term are also like terms. We already said like terms are terms that differ only in their coefficients. Okay, then this term and this term are also like terms. So we add and subtract like terms. So 3x squared y, and in order to do that, what you need to do is just to add and subtract their coefficients only, then you maintain the variable. So 3x squared y minus 4x squared y is practically, so 3 minus 4 is a negative 1. So we have a negative x squared y there, right? Minus 2x, okay? A term is always read together with its sign. It's very important. Common mistake will be to say this is 2x, to say 2x minus 6x. Wrong, all right? You need to always read a term together with its sign. This is very important. So this is not 2x, but negative 2x. Negative 2x minus 6x, right? So we just subtract their coefficients. Minus 2 minus 6 gives me a minus 8. Then I maintain my variable x. Then 1 plus 3 gives me a positive 4. Okay, and that is my answer. The subtraction of two algebraic expressions. Now, apart from addition and subtraction, we can also multiply and divide algebraic expressions, basically, right? So it's either we multiply the algebraic expressions by multiplying two expressions or constant multiples, multiplying one expression with a constant. We can also do that. All right. Okay, so let's look at an example there for multiplying the algebraic expressions. So if you look at that, multiplication. So multiplication involves, now before we move on to multiplication, I would like us to look at how we can add fractional algebraic expressions, basically. So let's look at multiplication. So let's look at a scenario where we constant multiple scenario where we want to multiply 3 times 5t squared plus 3t minus 1. Okay, so we can multiply algebraic expressions like this by multiplying the 3 by each term in our bracket. Okay, that's how the multiplication works, so that we get a 3 times 5t squared plus 3 times 3t minus 3 times 1. Okay, and it gives us a 15t squared plus 9t minus 3 as our answer. Okay, or we can also multiply algebraic expressions by actually multiplying two given expressions. For instance, 2t plus 1 times 3t plus 2. Okay, and we need to multiply these expressions. So what you do is to take each term and multiply both terms in this, each term in the first expression times both terms in the second expression, basically, and write down your answer. So I take 2t, multiply each of the terms in there, plus 1 times each of the terms in there, adding up the answers I get. So in this case, 2t times 3t will become 6t squared plus 2t times 2 will become 4t plus 1 times 3t, 3t plus 1 times 2, 2. Okay, and that is my solution. So I can simplify further by adding like terms, like we just saw. 6t squared plus 4t plus 3t, 7t plus 2. So notice that 6t squared and 4t are not like terms because we don't have any t squared. The variables are not the same, all right? What makes terms alike is the similarity in their variables. The variables must be the same. They must differ only by their coefficients. So don't get this mixed up. All right. But then 4t and 3t are like terms because the variables are the same. tt, the same. Okay, so we can add up their coefficients and combine them as like terms. Okay, so those are the two forms of multiplication, basically. Let's look at this other example, which involves 3 terms in the second expression. It says 2t minus 3 times 5t squared plus 3t minus 1. Okay, so if we look at this example, so the method applies in the same way. This term times each of these guys, all right, adding your answers. this term times each of these guys minus this term times each of these guys, basically. Okay, like that. So we start with 2t. 2t times 5t squared becomes 10t cubed. Notice how I got my 10t cubed using my laws of exponents. That's why we started this chapter with the laws of exponents, because we knew that we needed to use it in the subsequent sections. So just quickly, let me just quickly recap that. Look at this. 2t times 5t squared. All right. So the laws of exponents says when you are multiplying expressions with the same base, t, same base, you can add their powers. All right. So first of all, I do my 2 times 5 and I get a 10. Then I do my t times t squared. By laws of law 1 of exponents, I add up their powers. 1 plus 2 gives me a t cubed. That's how I got to my 10t cubed. All right. So you need to always apply your laws of exponents when you do, especially multiplication of algebraic expressions. Your laws of exponents will be very instrumental there. Okay, so it's next is a 2t times 3t. All right, by the same method I just illustrated, we get a 6t squared, right? And then 2t times -1, we get a minus 2t. Okay, so we are done with multiplying 2t by each term in this bracket. Now we are multiplying -3, not just 3, but -3. Always read a term together with its sign. We multiply -3 by each term in this bracket. We get a -3 times 5t squared. All right. So it's a -3 times 5. It gives me a minus 15t squared. -3 times -3t. So -3 times 3, times positive 3t. Okay. -3 times 3 is a minus 9t. Then -3 times -1. Minus times minus is plus, positive 3. Okay, then I look out for like terms and add them to get my final answer. So t cube, we have only one t cube, so it doesn't, it's not like with any of the terms. We have t squared there and t squared there, so we can combine these two as like terms. All right, 6 minus 15, okay, should be 9. 6 minus 15 should be -9. Then t squared minus 9t squared, and 2t and 9t are also like terms, right? It's a minus 2t minus 9t. Always read the term together with its sign. This is so important. That's why I'm stressing on it, because these are common mistakes that students will normally make. So it's a -2 minus 9, which is a minus 11t. Okay, your calculator can always give you these values. All you need to do is just add up or subtract the coefficients only, then you maintain your variable, basically. And then 3 is the only constant term, so we just have 1 plus 3, and that is the final answer from multiplying those algebraic expressions. Now let's take a few examples from. Now, before we take the examples, let's look at division of algebraic expressions. Okay, division of algebraic expressions, basically. So, we can divide algebraic expressions in 2 ways. It's either we distribute, right? So in cases where it's directly divisible, okay, where each of the terms in the numerator contain the variable that's in the denominator, we can divide by distributing the denominator to each term in the numerator and simplify. Okay, however, if that's not possible, then we use a method called long division to carry out our division. Okay, for example, given x cubed plus 3x divided by x, all right? So we see that x is in the denominator and x is in each term in the numerator. So it's easy for us to just distribute the denominator to every term in the numerator and then divide using our laws of exponents. So our law 2 of exponents is if I am dividing expressions with the same base, I can simplify by subtracting their powers. So if I do that, then this first term becomes x to the 3 minus 1 plus the second term becomes 3x to the 1 minus 1, okay? Which gives me the x to the 2, okay, which gives me an x squared plus 3x to the 0. And we know by one of the laws again that anything raised to the power 0 is 1. 1 times 3 is 3. So this whole thing boils down to x squared plus 3. Okay, so this is one way that we can divide if it's directly divisible, right? We take another one, 4z cubed minus 8z squared plus 3z divided by 2z, basically. Okay, so z is in the denominator and each term in the numerator also contains z. So we can easily divide this by distributing these guys and using our long division method. Minus 8z squared over 2z plus 3z over 2z, basically. So this becomes 4 over 2 times z to the power 3 minus 2 by our 3 minus 1, right? By our laws of exponents. So this 4 over 2 is this 4 over 2. Z cubed over z becomes z to the 3 minus 1, basically by law 2 of exponents, minus 8 over 2 z to the 2 minus 1 plus 3 over 2 z to the 1 minus 1, basically. Okay, 4 divided by 2 is 2. So this boils down to 2z to the 2. It's 3 minus 1 is 2. Minus 8 divided by 2 is 4. Z to the 1 plus 3 over 2 z to the 0. Okay, so our final answer is 2z squared minus 4z plus 3 over 2, since z to the 0 is equal to 1. Okay, so that's the first way of dividing if it's directly divisible like this. Kindly note that we cannot, right? This is very important. We cannot distribute numerator to denominator the way we distribute denominator to numerator. Okay, for instance, common mistakes I've seen students make over the years is to say that since we said x cubed plus 3x over x is equal to x cubed over x plus 3x over x, then they can also then say that since this happened, I've seen students also then do this, all right, which is wrong. Also then say that given, for instance, x over x cubed plus 3. Then they say it's equal to x over x cubed plus x over 3. This is completely wrong, right? This is wrong. You cannot distribute. The denominator is usually just one term. You can't put it apart. Okay, basically you can't scatter it, if I can put it that way. All right, it just remains the same. You can only distribute the denominator to terms in the numerator and not vice versa. Take note of this. All right, and not vice versa, basically. Okay, let me just take this out. And we move to the other method of dividing when all the terms in the numerator don't necessarily contain the common variable in the denominator. All right, when it's not directly divisible, then we use what we call long division, division by long division. For example, okay, so that's called long division method. Long division. Okay, so take very good note of this and make sure you understand it very well, because it's also a predominant topic in the scope of most of your assessments. So long division is used to divide expressions like 2x cubed minus 14. Okay, I would like to use 2x squared. I'd like to use a much straightforward example, x squared. A much straightforward example such as x squared. Let me just I'd like us to just use a more basic example before we go to the more complicated ones. So x squared plus 5x minus 3 divided by x plus 5. Okay, so x plus 5 is not necessarily any term in the numerator here. Okay, so it becomes difficult to divide this kind of expressions with the method of division that we just saw a while ago. Okay, so in this case, long division then comes in to help us carry out this division. So long division takes the form, dividend divided by divisor is equal to quotient plus remainder over divisor, basically. All right, this is the form for long division. Dividend over divisor equals quotient plus remainder over divisor. So this is called the dividend and this is called the divisor. Dividend and divisor, long division, basically. So in order to carry out long division, we have the long division sign, which is like a radical sign that wherein you put your dividend and your divisor, and you keep dividing until you can no longer divide. So our dividend stays in there, minus 3, and our divisor comes over here, right? Then our quotient will be up here and our remainder will be somewhere down there at the end. Okay, so the procedure is as follows. You take the first term in your dividend divided by first term in your divisor, all right, and put your answer there in the quotient space. Then you take that quotient times each term in the divisor and then put the answer of that multiplication underneath the dividend, then subtract your answer from your dividend. Okay, so you keep repeating this process until you can no longer divide. And when can you no longer divide? You can no longer divide when remember that each time you subtract, you get a new dividend. Each time you subtract, you get a new dividend. Okay, you keep getting a new dividend until the highest power of x in your dividend becomes less than the highest power of x in the divisor. At that stage, you can no longer divide, and the dividend you have at that time is called your remainder. Okay, so let's do this for better understanding. So we divide x squared divided by x, all right? So x squared divided by x, by your laws of exponents, this becomes x squared minus 1, which is x, okay? Your laws of exponents is super in this section. So it's x. Then take that answer and multiply each term in the divisor and put the answer down there and subtract. And you keep repeating that process until you can no longer divide. All right? So this x times this x is x squared, and this x times 1, positive 1, is positive x. All right? Plus 0. So the reason why I added the 0 is just so that I make sure that every term in my dividend there has a corresponding term, like term, down here that I can carry out subtraction on. Okay, so after multiplying, I didn't have any term that corresponded to my 3, so I just added a 0, all right, to have a correspondence for subtraction. Now, I usually encourage students to always put this bracket here and put the minus sign in order not to get your signs mixed up. This is very important because in this case, it's quite straightforward because we only have addition signs in between our terms, all right? But in some cases, okay, for instance, as I'm subtracting now, x squared minus x squared is 0. 5x minus x is 4x, and minus 3 minus 0 is minus 3. Okay, now imagine this was a minus. Okay, for instance, let's say this was a minus and you didn't put this negative sign. Okay, let's say this negative sign was not here. Okay, let me just take it out quickly. Let's say we didn't put this bracket and this negative sign, and this was a minus, and we are actually subtracting. Now, common mistake will just be for you to say 5x minus x, and you get 4x, which is wrong. Okay, whereas if you had put your negative sign, you will see that this is 5x minus x, which is actually 6x. Okay, so when it comes to negative signs in between the terms, it becomes a bit complicated. It becomes very possible for you to make mistakes if you don't actually put this minus sign there and work it out. Okay, so let's continue. So from there, I have a new dividend here, a new dividend that I now divide. Take this, so notice that every time you carry out your subtraction, the first term will always be 0. First terms will always vanish, all right? Every time. If they don't vanish, then you have made a mistake somewhere. They must always vanish, okay? So we then have a 4x divided by x, right? It's there, 4x divided by x. Just do this by the side. It's going to, by the laws of exponents, be 4x to the 1 minus 1, which is 4x to the 0, which is 4, basically, okay? By the laws of exponents. So it's a 4, positive 4. Take this answer, multiply each term in the divisor, put the answer there and subtract. 4 times x, 4x, and 4 times. So we are now ready to multiply our 4 by each term in the divisor. 4 times x is then 4x. 4 times positive 1 is positive 4. Again, we carry out subtraction. Okay, same procedure until we can no longer divide. Now 4x minus 4x is 0. As I said, first terms will always vanish whenever you subtract. All right. Minus 3 minus 4. You see, if you didn't put this bracket and this minus, common mistake would be to say minus 3 plus 4. I've seen students make these mistakes over and over again. Okay, which will give you a different answer, definitely. So minus 3 minus 4 then becomes a minus 7. Okay, now looking at our new dividend, there is no x in it, which means the highest power of x in this dividend is 0, which is lower than the highest power of x in the divisor, which is 1. All right, so therefore we can no longer divide. And so negative 7 is then called our remainder. We can no longer divide, and negative 7 is then our remainder. Okay, so our final answer in the form quotient plus remainder equals divisor will then be, answer will then be quotient is x plus 4. Okay, remainder is negative 7 over divisor, which is x plus 1. Okay, and that is the final answer to that long division problem there. So that's long division in a nutshell. Okay, let's look at a couple of mixed examples on how to carry out operations on algebraic expressions, basically. Okay, so we are up to problems. We are on to problems 4.0.4 now. Problems 0.4. Okay, so I'll just pick random problems from 0.4 and solve with you. So question 1 says that we should carry out or perform the indicated operations and simplify. Perform the indicated operations and simplify. So for the sake of the length of this video, I would like us to end this video here and continue with the problems in the next video.